Marco. So good afternoon, Marco. Marco is not, he's connecting again, probably.
Yeah. In the meantime, good afternoon.
There was a drop. So it's you were just inviting me to talk.
Yes.
Yes, it's my turn. Yes, I'm sorry, but as usual, when you have to start talking, the connection drops. So very, very briefly, I would like to thank Professor Brovelli for the excellent work she's doing in the framework of this bilateral project. As Maria Brovelli said, the first year is faster, but was productive, intense. I have been following your activities, and I have to congratulate with you and with the Vietnamese colleague for the excellent job you have done. And as you said, especially for your initiatives about these teaching initiatives that you have developed, which was not planned in the project. It's your fantasy, academic fantasy, allow you to develop with the support of the Politecnico of Milano these initiatives. That is very much appreciated. And as I told you, I also appreciate the fact that you share this experience with the colleagues from the projects, because I think it's really a very good way of exploiting 100% the resources and the possibilities that these projects are offering. And I'm very glad to be here to listen to the presentation by the students. And as I was just mentioning before to Professor Brovelli, the very big news we have this year is that finally Vietnam is opening the borders, theoretically from the 15th of March. Practically, we don't know yet. It's not yet possible just to apply and get the visa from the embassies. I know from some colleagues that tried to get the visa, there were some problems, but I hope that within a few weeks, I will be able to send a message to all the principal investigators of the projects saying that visa are open and is easy to come to Vietnam. At least for the 2 weeks visa, it should be really very, very easy. And visa are going to be open for people participating in the project, but I take the opportunity of the fact that we have the Dean of the School of Civil Environment and Territorial Engineering of the Politecnico to say that also to promote the internationalization of the Italian universities, it's possible to organize visits to Vietnam and to visit different universities like the University of Civil Engineering, which is one of the top universities in Vietnam, to promote the exchange of students, exchange of PhDs, exchange of staff. So you are also welcome to come to Vietnam. And if you decide to come, I will do my best to organize a proper agenda, very busy agenda for you to, to visit the colleagues in the Vietnamese universities. And I also would like to thank Professor Brovelli for the initiative of preparing an Erasmus application as a follow-up of this project, and also the colleagues that are available to participate in the workshop that we're organizing in Quignon at the end of May, the 27th and 28th of May. This workshop is going to be fully dedicated to promote the Erasmus projects between Europe and Vietnam. And I want to stress to you that Italy has had in the last 7 years, 2015, 2021, which are the Horizon 2020 project, Italy had 28 Erasmus projects with Vietnam. We were ranking second after Spain, and we're one of the most successful countries in the exchange of, in the framework of Erasmus. And I hope that next years is going to be very, very productive as well. And the last point, in September, October this year, we are going to have the midterm evaluation in Rome with the colleagues from the Ministry of Science and Technology of Vietnam. And there we will do the assessment of the state of the art of the project, and also we'll start drawing the guidelines for the next call that is expected to be published in the spring 2023. So we expect that in April, May 2023, a new call for project between Italy and Vietnam will be published. That's all. Thank you again, Maria, for your excellent work and for all the activities that you have promoted during the project. And I'm really glad to be here with you today. Thank you.
So thank you so much, Professor Abbiati. Very interesting news also. And yeah, I'm looking forward to coming to Vietnam. You know, I already went there some years ago, and yeah, I want to come. Let us see if with the dean or if the dean can't come alone, but I'm looking forward to meeting also the colleagues at Vietnam with whom I have worked the last year and also prepared this Erasmus. Let us also keep fingers crossed because we did, in my opinion, we did an excellent proposal. It's not because we wrote it, but I'm satisfied about the proposal. And so let us hope to be also lucky, because sometimes when there are many proposals, it's also difficult to succeed. And but we did the best, and so let us hope for the best as well. And say that, and having and thank you again. There is somebody speaking with the microphone open. Please, if you can check your microphone if it is switched off. And then at this point, I will leave the word to the Dean of Politecnico, because it was thanks to him that we were able of organizing this joint lab. And so, Professor Tagliercio, the floor is yours.
Thank you, Maria, for inviting me. I hope that you can hear me. As Maria said, I am the Dean, not of the Politecnico, of one of the schools of Politecnico, the School of Civil and Environmental and Land Management Engineering. So thank you for inviting me. It's real pleasure to welcome all the participants to this workshop, people coming not only from 2 different universities, but from different countries all over the world. The course of Geographic Information Systems is one of the courses of Politecnico that has been involved in a new program, a wide program that was launched last year by Politecnico di Milano, which aims at making our courses more interesting and more effective for students. And to do this, we are using the tools and the devices that we have to equip with for remote teaching in order to face the pandemic emergency. And now that this emergency is behind us, or at least we hope that it is behind us, we can profitably use these devices, for instance, to allow students all around the world not only to share teaching, not only to share professors, but also to cooperate in joint workshops and joint research programs. You are one of the first groups that is experiencing this pioneering new learning approach. And I do hope that it was a fruitful and exciting experience for you, all of you. I'm pretty sure that it was. And maybe this was not only an opportunity to get new remote classmates, but also to get new friends from all over the world. So I don't want to lose more time. I wish you a fruitful and interesting workshop. Unfortunately, I cannot stay with you because I have to go and teach. And thank you once again to Maria and our colleagues. Bye.
Thank you so much. Thank you so much for your continued support to this initiative, and have a good lesson. We know that all of us, we are very busy with lessons as well. But so let us start the presentation of students, because I believe that today they are the protagonists of what we want to present. And we want really to see what are the results of the projects they worked on. So the first group is a group from Vietnam, and I hope to be able to say the name correctly in case you will correct me. So the group is a group of the Hanoi University of Natural Resources and Environment. The names are T-Oi Tu Tring, T Tui Dao Bui, Hoang Min An Tiu. So I hope that at least you can understand.
Sorry, Maria.
Yeah.
The group one they have problem because one the leader group is on the hospital because sorry about that. Her husband have some problem, and the second one she's have some problem with internet connection, so we can switch them at the end of
At the end. So
sentence.
we can start with the third.
The second one, yeah. Please start with second one.
But so at this point, it's better if you say their names in such a way that the names are correct.
Okay. Okay. So I would like to invite the group 2 to the beginning to start our presentation today in the Vietnam side. Group 2, Nguyễn Văn Hoàng and Trần Nhật Dương. They are from Vietnam Institute of Geoscience and Mineral Resources. Please, Jill.
Thank you for inviting me to present on the workshop today.
Good morning. Good afternoon.
Camera Dương ơi.
Who is going to present in such a way? Okay, now it's sharing the screen. Fantastic.
Okay, so good morning and good afternoon, ladies and gentlemen. Okay, so on representation of Group 4, I would like to present about our group final report on the GIS course. Okay, so here I will go directly on the methodology of doing the landslide susceptibility map and do the population exposure assessment. So I will do 5 steps to generate the landslide susceptibility index. So in the step 1, I will need to prepare the data for the for running the model of susceptibility. And in step 2, I from the collected data, I will produce the training and testing data set. And in step 3, I will use the collected data and also the training and testing data set for the model and the model called the model map and written in R language. And then I will validate the model by a Python script to compute the accuracies of the model. And in step 4, I will do the population exposure assessment to see in which hazard zone, how many percentages of population are exposed to the landslide. And finally, in step 5, I will deploy the data on GeoServer and building the WebGIS website. Okay, so I will skip the technical step, and here is my our group area of interest, and it looked like this. Okay, so after I do the running the model map, I will obtain the landslide stability map like this in the left hand side, and I reclassify the map into different hazard zone with the low, moderate, high, and very high severity. And I do the validation of the model, and the accuracies, overall accuracies of the model is approximately 68%, and I visualize them in visualize them with the population counting. Yeah. And also, finally I deploy the data on the website, and then I got the website like this. Here, yeah, I take all my advantage of building website and design to design the logo of our group and the layout for the website, and I added the map section here to visualize all the data of the processing and show my my knowledge gained by the GIS course. Yeah. So I would like to break the line here, and thank you for listening.
Thank you a lot, Tran. Very good work you did. I have only one question for you, very quick, because there is not question now, but I want to know if you can share the link to the WebGIS in such a way that also our guests, like for instance, Professor Abbiati, if he wants, can go and play with it. So if in presenting, then you can share also the link to the WebGIS. That is can be very interesting. And thank you for your presentation. Thank you. So I believe, yes.
Yes, Maria, we will do that now. Geom, that is Geom who just presented.
Yeah.
He's just deploy only in local machines, I think, but we can put it in the our server, because we have to. We already ran the server there. So the next second group will have the online website. Okay, yeah. So can I invite the next group?
Yes.
Yeah, okay. So I invite group 3 to take the second presentations. Miss Nguyễn Thị Hoài Thương, Lương Thanh Tâm, and Miss Trịnh Thị Thắm from Hanoi University of Natural Resources and Environment. Please go ahead.
Okay, hold on a second.
There is something not working. So who is going to present?
I think Thương. She said hold on. This is been appearing soon. Yeah.
Okay. Okay. But I don't know what's happening. Because I don't see the presentation shared.
Sorry, please wait turn at the moment because her computer have some problem. Her now she is preparing to show presentation. Okay, hold on a second. I am trying to show my presentation right now.
Or we can do in this way that we start with the first presentation of the Polynese students, and then we go back to this presentation in such a way not to waste time. So the first presentation of Politecnico di Milano is a presentation given by Alessandro Austoni, Daniel Alberto Aguirre, and Juan Francisco Amieva, which is an international team of students. Okay, so if you are ready, please, you can present now.
Yes, good morning to everyone. I will share my screen, but we will all get to talk.
Okay, good morning, Daniel.
Good morning, everybody. Okay, that's all set up.
Okay, I think we can start. So, good morning, everyone. I am Alessandro. Today I'm here with my colleagues, Daniel and Juan Francisco, and we will show you our work for the landslide susceptibility and exposure analysis project. So first of all, we would like to start by briefly showing you our area of interest. Our area is centered in the Tirano city, and this area in particular, let's say Tirana is a city that is located in the northern part of the Lombardy region in the Sondrio region. And in particular, here we have a population that goes from 14,000, 15,000 inhabitants. The surface is about 131 kilometers squared. And here we have showed the coordinates for the Tirana city. So we started from, like everyone else, from a set of maps, in particular the DTM and the NDVI and other layers. From there, we computed other intermediate maps in order to then sample some points to give to a random classification and produce a final susceptibility map. So here we have our first output, which is the susceptibility map, where we can see the risk of landslides in the various areas. And in particular, we will see maybe better later with Daniel in the WebGIS part, but we have also produced an exposure analysis for the population. And a first result that we have obtained is that if you can see maybe in this susceptibility map, we have a region, a sort of strip going all over the middle of our area, which is the gray one. And this strip is considered like safe. If you see from the legend, maybe it is a little bit small. This is because it is a very flat area where the road and the river are passing. And for that specific reason, if you see later maybe better the raster of the population, we can see that the population is mainly centered in that area. So that's why the population is not so exposed to the landslide risk. So we have also created a WebGIS, which for the backend is mainly based on GeoServer. And now I will leave my word and the floor to my colleague Juan Francisco that will show you our two different approaches that we have used to tackle our work.
Good morning, everyone. Well, here the idea is to explain you the two different approaches we consider in our analysis. We started with a first approach that considers just 1,000 points to train our random forest model, which is a supervised algorithm. In this first approach, we consider a train test ratio of 70-30% respectively, and we obtain an accuracy of 72%. Then, by increasing the number of points, we reach an overall accuracy, keeping the same train test ratio of 79.5%. It means 7.5 percentile points. As was introducing Alessandro in the previous slide, we noticed that the main percentage was of the exposure classes was in the low risk areas. Also, in the transition between the first and the second approach, we observed a displacement between the higher risk areas towards the lower one. And this implied an increasing in 7% of the low risk area. Now my colleague Daniel will continue with the WebGIS demonstration.
Thank you very much, Juan. For the WebGIS, we have it locally deployed in my machine. Okay. So for training the results of our project, we developed this web page to let people interact with our results. This is all based on open source software. Here we are exploiting the fact that we can use the GeoServer to show our layers in this widget map. As Juan Francisco was mentioning, we have the two approaches in terms of the susceptibility results. We also included a tool to slide in between the two results to see how the high risk areas are reduced. And also what earlier Alessandro mentioned is that most of the population here in this particular area lives in the flat part. We can also see the layer for the susceptibility. We included some analysis of the accuracies, the respective accuracies, and the changes in the susceptibility for both. In terms of the results, we can also see the exposure analysis here in like brighter colors. And as you can see, I will switch to the population. Most of the population is living on the urban area of Tirano, which is the lowest risk stripe, so to speak. We included also some explanation of the processing and the input layers so that users can interact with the input information that is fed to the algorithm, and also some data about us as a team. So with this, we wanted to like use all the tools available and that we learned throughout the course to portray our results in a interactive way. Sadly, this is just running here on my machine, so I cannot actually share the link to the web page.
Thank you. Thank you very much for the excellent work you did. Yes, we have to find a way to publish somewhere in such a way that to make it available, this work for everyone, also for you, as a matter of fact, because I believe that it's good for students to have the possibility of showing what they are able to do, what they are learning in their courses. And so thank you by now. And then please stay here, because if there are some questions, we will ask the questions in the end. And on the opposite, let us see now if the Vietnamese team is ready for the presentation.
Alo,
Yes.
Thương ơi, Thương và gì nhỉ? Nhóm của Tâm ơi. Are you ready for present?
Yes.
Okay.
Okay, wonderful. Thank you. And thank you again to the team before, because congratulations for your work. It was an excellent work. And let's consider a new case in Vietnam now.
Phương ơi.
Okay, I'm
Được,
here.
bây giờ mới nghe này.
Okay. Good afternoon, everyone. We are group number 5 from Hanoi University of Natural Resources and Environment, and my name is Thương. Today, I would like to represent my group to share the result of our lab projection. So, following the lab instructions, we build landslide susceptibility mapping in 5 steps as follows. Step 1 is data pre-processing for susceptibilities mapping. Step 2 is susceptibility mapping generation. Step 3 is data pre-processing for exposure assessment. Step 4 is exposure assessment, and the final one is develop to website and web GIS. So beginning with the step 1, we download the providers, dataset, and geo package from for pre-processing. They include the following file: landslide inventory.
Sorry, I think we lost your sound.
Yeah.
Thương ơi, em bị mất âm thanh rồi.
I'm sorry. My internet is not unstable, so okay, come back to the presentations. Listen to feature geological fauna. Listen to feature river geologies. Normalize different vegetation index. And on the screen, the left-hand side is the project area of group number 5, which have been circled. And the output of step number 1 consists of environmental factor map, include digital terrain model, NDVI express, geologies, post plant profile, river road slope, non-landslide zones, training point sample, and touching point sample. So below the step, we have tokens and result. We click on the raster and vector layer of the growth area, and then we vectorize on the vector layer except the landslide inventories. In this step, we use distance attributes as burned in values, set vertical and horizontal resolution equal to one of the digital terrain model in the matrix units. Assign the outputs it can equal to one of the digital terrain model as well. Then extract the factor from the DTM, I mean digital terrain model. It is include aspects, slope, slope angle profile, curvatures, and plane curvatures. So the integrations of aspect and slope map is straightforward. While plane and profile curvature map, we use the values of below zeros, equal zeros, and or above zeros. The next, we clip the landslide inventory layer, use the mass as a vector layer of the area. Then define area with the low possibilities of landslide according to the slope angle. We assume no landslide zones when where the slope is less than 20 degrees and above 70 degrees. And we finally vectorize the result raster by using raster values as categories to obtain the polygons of non-landslide zones. Here. And the next, we create new file hashes to the attribute table both landslide inventories and non-landslide zones. Assign 0 to the non-landslide zones and 1 to the landslide inventory. So in this, we choose the training testing ratios of 70-30. So then we select the percentage of the polygons for training and testing according to the both landslide inventory and non-landslide zones. Then we create random points inside the polygons. We have 37 landslide points, so we have make 37 points inside the non-landslide zones. So in this case, we have 26 training points and 12 testing points. And then separate the training and testing layer into the two part layer, training and testing point here. At the end of this step, we have a two-layer training point sample and testing point sample with attribute table here. You can see it on the screen. Move to step 2. Before continuing with the following step, an Earth model map in GIS, we check on the environmental raster to consistent and have the same coordinated reference system, distance, and resolution. We run our tools and validate our outputs. And then we classify the result layer into two classes, zeros and 1. Here, you see the result. Then for validating the result map, will be used accuracy assessments and sampling by Python script. And this is the output of step number 2. This is landslide susceptibility map and error matches from the validations. So look at the error matches from the validations. Overall accuracies come out to 90%. That means our model was right. It's good enough. And move to step number 3. We develop population raster datasets from the provider website, and then we process the population raster datasets using the same coordinated reference system of the group 5 area vector layer. And Then we reclassify the susceptibility raster map using 4 classes such as here below 0.25 from 0.25 to 0.5, from 0.5 and to 0.75, and above 0.75. And continue with the step number 4. Here's the table to show the result of compute the population counts in each susceptibility class by using quizzes process tool. Here is 130,461 people are severely affected here. And this is exposure assessment plus the percentage of population for each susceptibility class by using quizzes plotted data plotting. So the result of exposure assessment of group 5 is 56.9% population in a low susceptibilities class and 9.60% population in a high susceptibilities class. Move on to the final step, is step number 5. Develop a web GIS. And this is the result. And then we continue to develop a website, susceptibility raster map. And here's the website address. Okay, that's all. Thank you very much for your listening. Yes, thank you for your support and happy in the course with your health and success. Thank you.
Thank you so much. I'm so happy to see that in the end, all the students did a very, very excellent job. So we were able at least to communicate them correctly how to manage this problem, which is a relevant problem in Italy and in Vietnam as well. So thank you so much. And I saw that you have also the WebGIS already available. So that is also interesting because it means that people are able to check what you did. Thank you for the excellent work. And
okay, thank you so much.
Then at this point, we go to another presentation of
yes.
the Italian.
Yes. I think can we finish the Vietnam side first? Because
okay. If the
they
team
are
is ready, yes. Why not?
Please, Please, group 3. This means the presentation 1. Please present your work. Thank you.
Then while they are connecting and sharing, I want also to thank Professor Biaggi, who is the head of the course of Geoinformatics engineering course, because he also supported this initiative with students. And then I want to tell you that he's going, not he, but one person working with him is going to present in the end of this meeting the work that was done related to deep learning, which is more advanced, obviously, with respect to the students did in their work, but is again part of this activity of this joint project. So thank you, Professor Biaggi as well. And then is the team, the Vietnamese team, ready for their presentation? Quang?
Hello?
I'm here. Wait, please. Sorry. my internet has some problem. I changed my laptop. Can you see
Yes,
my
yes. Yeah.
my presentation? Yeah.
It is
Hello,
a strange,
lady.
it is a very strange logo of the Politecnico di Milano. Are you sure
Yes.
that this is the
Yeah,
official?
yeah.
Are you sure that this is the official logo of Politecnico di Milano? Because it doesn't seem it.
Sorry.
I think they we take it from took it from internet. That is problem.
Yeah, but probably
I-
it's better to change it.
Sorry, I succeed.
That's terrible.
Yes.
I will change. I will change.
Yes, please, before sharing the slides, definitely. Thank you.
Sorry. Hello, lady and gentlemen. My name too from University and National Research and Environment. Today, on behalf of Group 3, I would like to present our results. Our results presentation consists of 5 parts. Firstly, data pre-processing for susceptibility mapping. Second, susceptibility map generation. Data processing for exposure assessment. And a post assessment finally develop a website and website. Our study is a part of Văn Yên district in Bai province of Vietnam. In Vietnam, our study course is there. We is located to the north of district with an area about 194 square kilometer. We used critic to click all that vector layer and vector layer using mask the vector layer of the sub area. Extract NDVI, extract slope. Slope effect profile and plan from them. That's just after step. NDVI, GEOLMIV, force, driver, rod, slope effect plan profile. And define area with cloud possibility of landslide according to the slope angle. We give no landslide, no landslide zone, and landslide inventory. We select 60 random point for training and testing for model from we used 40 point for training and 60 to test for compliance. One by one ratio. Or environment factor might have factor might have a vector with the same resolution and extension as clipped them. We run the routine using random forest model to create susceptibility map. The result is a landslide susceptibility map and an error metric from the validation with the overall accuracy 60%. So, sorry, can you see my presentation?
Yes, yes, we can.
Yes,
thank you.
And the landslide stability show that value with less under 6.006 no, sorry, under our 0.20 parenthesis as allow stability of landslide from 0.25 to 0.5, it creates a moderate susceptibility of landslide. And back when 0.5 and 0.75 so high susceptibility of landslide and rate than 0.75, including error that have a very high susceptibility to landslide. This sample was the classified susceptibility vector map using extension and resolution of the collected population just data set. We can post the population count in X susceptibility class. Our class our input there. After that, we public on we public on is our website. This is our website. Yeah. Yes.
So thank you. So also in this case, we can go to the website and play with it. Meanwhile, I want to say hello to Professor Abbiati. Thank you for being here. And then obviously you are very welcome if you are able to come back later when you finish this short meeting you have. Thank you.
Yes, thank you.
That's fantastic. We can see the website so everyone can check and browse in the website. Thank you. Thank you for your work as well. And then, because we are just a bit late, let's go ahead with the next presentation of the second Italian team. So Giulia Anna Leonardi, Zainep Zena, Oksonul, Maciej Krzysztof, it's too difficult also, Zerwuski of Politecnico di Milano. So now the floor is yours.
Okay, thank you so much, Professor Brovelli, and hello to everybody. I will share the screen. Unfortunately, Maciek is not in the meeting, but I will present for both of us. So I will start sharing. Okay, so I hope you can see my presentation.
Yes, yes.
Okay. So as my colleagues before me explained all the procedures, I will be mostly concentrated on what we did in addition to the steps that were proposed by the team. And I will start with the aim of the analysis. So as I said, we by default computed the landslide susceptibility map of the region and developed a WebGIS with the results, which I hope we'll have time to present also. We performed an exposure assessment. We did it also on an infrastructure layer, not only on a population layer, to see how those two will relate to each other. And then we also did some additional analysis on different data sets, as also the group of Juan, Daniel, and Alessandro did on different data points count, and see how they will affect the results, as well as we also tried to manipulate a little bit the ratio of the test and train data set to see how these will affect the results of the analysis. And then we also checked how all of these manipulation of the data will at the end influence the exposure assessment to see how data manipulation can change the results of such a complex analysis in the end. The area of our analysis was the valley south of town Bormio. It's showed here in the map, and this is the close-up. The area is, it's in a mountainous area, so it's obviously prone to such events as landslides, but this one in particular is close to Valtellina and is actually known for one of the most dramatic events that took place in 1987 and took 35 lives. So monitoring such areas in respect to landslides, I think, is well justified and needed. Moving on to the classification. As I said, we created two different data sets composed respectively of 1,000 and 2,000 points to train our random forest classifier. And then each of these data sets we split to different training to testing ratios. We did one data set for 70% for training and 30% for testing, and then an 80-20 ratio for each of the two data sets. So in the end, we ended up with 4 different data sets, and we ran the random forest 4 different times. And the result I will show here. The first thing we wanted to check was how the data count actually affects the overall accuracy. And I'm showing here the overall accuracy and not the user accuracy and producer accuracy, mainly for time reasons and simplicity reasons, but they are obviously very interesting as well to check. But for simplicity, the overall accuracy for different data counts were, as expected, increased and from just 71% of overall accuracy for 1,000 points, it increased to 81% for 2,000 points, and that was for the 70-30 ratio. Then we moved on with the 80-20 ratio, and for the data set of composed of 1,000 points, the results were also expected, in the sense that the bigger the training set, the highest the accuracy yielded. And so we got a 79% overall accuracy. What was interesting for us is that we were expecting the higher accuracy for the data set that was composed of the largest amount of data points and with the largest training set. That did not happen. It was actually lower than the 1,000 points data set for the 80-20% ratio, which was kind of surprising for us and very interesting. We concluded that, well, we ran just one random sampling of each point data set, and there was a higher chance of choosing a test set that could be biased, for example. That is more of a statistic and machine learning issue, but it was nonetheless very interesting to see in practice how the results can be affected by just one random sampling. Well, as I stated here, that nevertheless the obtained accuracies were all satisfactory, and the overall accuracy in each case was above 70%. Then we moved on for the exposure assessment and the results for the population and the infrastructure exposure. We wanted to compare the worst classified landslide susceptibility map with the best classified landslide susceptibility map. And then we analyzed what are the differences by analyzing them with these two different maps. And here are the results for the population. As we can see, the results for the WARS model were hugely underestimating the low hazard zones for population, as we also saw in the analysis that my colleagues from Politecnico before showed. For us, it was more than 10% actually, so it was very interesting to see the differences. For the rest, it wasn't, they were a little bit overestimating the very high hazard zones, and the same trend we could see for the buildings. As a matter of fact, here it was a little bit, the difference was a bit less, but it was the same pattern. So it was very interesting to see how manipulating the data at the beginning could affect the end results of such an important assessment, which is the exposure assessment for buildings and for population. And then we went to the conclusion, which was obviously that the workflow suggested by the tutors using the random forest can be successfully used in many different similar landslides analysis, as we also saw with the Vietnamese colleagues, that they were successfully applied to different regions. And the second thing that we concluded was that not always the biggest the data set or even the training set, the better accuracy yielded. It all varies, and it is very interesting to explore, I think, the data in such analysis, and that there is a significant difference in the result of the exposure assessment depending on the data set used. And if I have just 1 minute, I wanted to show the developed WebGIS. That is our WebGIS that was created by me and Maciek. And here is a little bit about the project, our region, and maybe what is the most interesting thing is the result. The approach, I think, was mostly showed already by my previous colleagues, so I won't be getting into the details, but these are our susceptibility maps. This one is the one that yielded the worst overall accuracy, and this is the one that got the best one. So we can see the change here, actually, that these regions were classified before as high hazard zones, and now with the better accuracy, they were actually classified as lower risk. And well, we can see also here the lighter area is the valley, which has the lowest hazard level. And yes, I also have it deployed only on my machine, unfortunately, so I'm not able to share our website. I hope we can resolve this problem in the future, so we can share it. But for now, this is yes, this is everything I wanted to show. Again, very much thank you for everyone for joining this interesting project, and I'm very happy to be here and see all the different results everyone got. So thank you again, and yes.
Thank you for your work. Very impressive. And yes, I'm so impressed by what the students both in Vietnam and at Politecnico did. I hope that you enjoyed the project as well, because I see that you learned a lot. So, and this is very useful, as a matter of fact. Not only interesting, is not only theoretical, but it's something that you can use in practice. And we know how important it is to deal with these hazards, like, for instance, landslides. So thank you again also for the commitment and the enthusiasm that you put in the project. Thank you. And now we go to the last one. So the last project again will be presented by Politecnico di Milano, and the people working at Zara Mini for Jabi and Siavash Montazeri. So I don't know, is the presenter?
Yes, Farooq will share the screen and.
Okay, Zara presenting. So we are also very happy that there are so many ladies presenting, so many women presenting.
Yeah, thank you, Professor. Good evening and good morning, everybody. The project was divided into two main parts. The first one was process the data environment factors that were given to us. And the second part was the code, both website and WebGIS. And for this, we required some tools such as OpenLayers and GeoServer. And according to some problem, we had to use a local version for sharing geospatial data for GeoServer. At the beginning, our main focus was in the first part, which was the processing the data. Then we worked on the second part as well. As a suitable case study, North Italy is chosen due to the abundant landslide events and high concentration of different landslide types. Our area was zone 8, which is located in north of Italy and contains part of Bergamo and Brescia, approximately covering Brescia. And this project mainly focused on two main goals. First, landslide susceptibility mapping, which depict the spatial probability levels for a certain area to be prone to mass environment based on movement based on environments conditions to implement a statistical based model of the random forest at the basin scale using various scenarios for the input data sets, training sample and ratio, and validation metrics. And the second goal was estimate the population in hazard zone to prevent the damages. According to studies, random forests achieve the highest accuracy in most of cases, proving to be a reliable modeling approach in comparison of different methods such as statistic index. And we decided for this project, each member do the steps separately. So we had different results, and by comparing the result of each member, we decided to base the one which had more accuracy for computing population per each susceptibility class after collecting all points, and all of them were stored in our website. And now my friend Fu will explain the detail of the steps.
Okay, as my dear friend Zahra said, we have to produce a landslide susceptibility map. So we need to prepare our data in order to use them for the random forest method, which is a machine learning algorithm for classification and regression, and gives us the possibility to create models, validate the results, and produce the maps over geographic areas. And therefore, we need environmental factors that each of them affects landslide, and also we need a landslide inventory map that has been provided for us, and that is a main key for landslide susceptibility mapping. About environmental factors, some of them have been given to us, such as road, river, faults, and DTM digital terrain model, and NDVI, that is normalized difference vegetation index, and land use, as you can see here. But the rest of it, we have to produce them, such as aspect, slope, and plan and profile. You can see here, with respect to digital terrain model for preparing and for preparing data, we clip them and with respect to our area, and then we resampled all of them except landslide inventory. Regarding the resolution of DTM, which is 5 meters, because DTM is the source of most of the morphological variables, and also its resolution is sufficient to be used for the local factors. At the end, all the environmental factors will be ready in GeoTIFF format. Since we need training and testing points for the machine learning model, we have to prepare both the landslide inventory map and no landslide zones map, and then merge these two maps. First of all, we need to produce no landslide zones map. So we have to find the areas with a low possibility of landslides according to the slope angle. And once we created this map, by removing the small patches and vectorizing it, then we have to create two fields for each of the landslide inventory and no landslide zones. That one of the fields named hazard, that is 0 for the no landslide zone, and and 1 for the landslide inventory, and the other field named train test is created by selecting randomly with a ratio of 70% for training and 30% for testing, because we believe that this ratio suits our model. Now we can merge these two maps, and then we have fed our model with 1,000 random points, which are 700 points for training and 300 points for testing, and each of them is divided equally with reference to hazard. For each point, the information...
Sorry, I want to ask you, because are you supposed to show us some slides? Because I see that it is, what we see is the local web GIS. Okay.
Local, okay, sorry.
Okay.
No. I have to, sorry. No, it's what happened. Okay. Okay, let me. And can you see my screen?
Yes, we can see the WebGIS, correct? This is what you want to show us?
Yes, but I wanted to show the table that that is the hazard and terrain test fields, but I think what happened? Okay, I think I have to stop sharing and then, sorry.
And sharing again, probably.
Yes.
Don't worry, it happens normally also during the lessons.
Okay, here you
Yeah,
can
now
find.
we see the table. Yes,
yes,
yes.
yes. That is the terrain test fields. And you can see we assign 0 and 1 to the hazard field, and terrain test that is randomly selected. Okay. And okay. Okay, now I want to show the my oh, what happened? Okay.
Okay, if you can conclude in short time.
Okay, yes, I'm almost at the end. Sorry. Okay, here. Okay, for each point that we created, the information from the environmental factors should be sampled to extract the underlying information. At the end, by using all the pre-processing data and the random forest machine learning algorithm in R for QGIS, susceptibility map is produced. And that is our susceptibility map. I want to show you. Okay. Okay. Once the susceptibility map produced, we have to validate the map by using sample testing points and reclassifying the susceptibility map with the help of Python scripts that give us the confusion metrics according to this table. The random forest method's average accuracy for our project is almost 72%. And for the second purpose of our project, we reproject the population raster here. We reproject the population raster dataset for our region of interest, reclassifying the susceptibility map using 4 classes, namely low, moderate, high, and very high was our next phase. Afterwards, we resampled the reclassified susceptibility raster map with respect to the resolution of the population raster dataset, and then we computed the population counts in each susceptibility that you can see in this table. And then we create a pie chart. According to this pie chart, 98.2% of people inhabit places where the risk of landslides is low, On the other hand, almost 1.52% are at the risk of losing their life or property. So appropriate action is highly recommended for these people. Thank you so much.
Thank you also for this very kind and nice presentation, and for the work that you did. So we have now finished the presentation of the students. I want just to let them know that this project with Vietnam is going ahead, at least for this year, but probably also next year. And so obviously, if there are students interested in going ahead, deeping into this topic, as a matter of fact, and not only with a small project for a course, but doing something more, obviously there is this possibility. So if you are interested in this topic related to landslide, please tell me, and there is the possibility of going ahead working on that. And thank you for all the presentations on the Vietnamese side and the Polynesian side. Thank you a lot. We will check how it is possible to publish the WebGIS in such a way to give evidence also to what you did. And now I'm leaving the chair of the event to Professor Quang, who is for my current students. Quang was before a PhD student of mine, so he was studying in Italy many years ago, and now is teaching at the university, at the Hanoi University, and so we had the occasion of working again together. But before he was a student of mine. And so I'm very proud also of your career, Quang. I'm very proud of what you are doing, and very happy to have the possibility of collaborating. And I really wish all my students to have the same possibility, but I'm pretty sure because they are very good, they are excellent students. And so I'm pretty sure that they will have a brilliant career as well. Okay. Thank you to everyone, and I will give the word to Quang. As I said before, I will leave for attending the final defense of a PhD, but you are in good hands because I know that what Quang is able to do. Thank you so much, and see you in class, to my students, see you in Vietnam with all the students, the Vietnamese students. Thank you.
Thank you, Professor Maria. Thank you. So I would take the part. First of all, good morning again, Italian side. So in 2010, I was student at the Politecnico Milano in the Como campus. So very nice to see you, both sides, Vietnam and Italian side. Let's say Politecnico Milano University. So I will summarize what we are in this session. I want to summarize what we have done and what we are doing, and make all of you better understand what we can contribute to society, to the governments, etc. So can you see my screen now?
Yes.
Yeah, thank you. So we are as a big group of Vietnamese scientists from 3 different universities and institutes to join this project. The name is Geoinformatics and Earth Observation for Landslide Monitoring. It's in the international name, let's say that. We all agree about that name, but in Vietnam it's a bit change the name because we have also science offices. they asked me to change the name, but we can understand this is geometric and Earth observation for landslide monitoring. Okay, so this is our live project. So today I want to let you know what we are doing and what is the future and the complete system of us and all the work component what we need to finish and hand out to the Ministry of Education and Technology, who is give us supporting for this project, collaborate with Politecnico Milano. So the outcome of project, what we need to hand over to Ministry. We should give a geospatial database for landslide assessment. It's similar to what you have like NDVI, like slope map, etc. What we can measure is about 17 classes, and we have to select the best machine learning models. They are including also including deep learning model to improve accuracy of in identify the and monitoring and forecasting landslide. And because this need a lot of data, so right now we interface preparing data for that and build a smartphone app to collect the landslide information. This is we follow the product already done by Politecnico Milano. I think there's from master student who's already developed it. And number 4 is landslide accessibility. We already have two machine learning model to have the outcome of landslide accessibility map. One is from what we are doing now, random forest, and because we have to build up the system, so we need to do like a real-time, near real-time system to warning the people if there is landslide can be happen or not, and some server report. So this is some kind of component we divided in input component and analysis component, what we all done, and also processing component is applying the different technique, different algorithm. Most of them is from machine learning, so you can like LSTM is a long short-term memory algorithm. This can predict the future, and or maybe CNN is good for predict the pattern of the image. Is good for to update up-to-date the landslide accessibility map based on image satellite images, or we can also use a hybrid model or maybe random forest or this regression is what we already know before. And the fourth component is I call that is model integration or system integration. It's similar to what you've done for the WebGIS, but we have to split everything and make the system running automatically as much as possible. And the outcome of the system can be divided in two blocks. One is landslide information, is about the map, the population, etc. And also maps, different type of maps, and also some early warning messages. And we use a system for warning the landslide happen or not. So the trigger factor here, most important factor in Vietnam is the rainfall. And there is also the climate change problem in Vietnam. So the rainfall data is very important. So rainfall data can be the output of our model. So here is some another point of view of the system. So you can see A, B, C, and D is belong to some work packages, and belong to work packages. We have some bidding package, because we have to pay money for buy UAV images. We use computer system and databases, and so we have to run the server, etc. And we have to understand better the geology and like hydrology for in the specific area. We have a big package for that issues. Okay. So in the first year project, so we have already finished step 5, but based on the budgets, we need to improve the accuracy of landslide sensitivity. This means we in Vietnam we don't have a very high resolution images like Italy, and they are not free. So we need to pay, or we need to collect by ourselves. That's why we need to do again. Like this is the work what we need to use UAV to collect the data around, and we update the landslide inventory again, and we will apply for landslide sensitivity map again in this period. And also we have some things like geology survey. Yes, we have to do in this phase. Our project start from last July. Now we already in the 9 months, so we have some month more to complete the first year project. So this is some work packages that you can see before. So the work packages almost related to geodatabase for building up the landslide sensitivity map, and also the artificial intelligence algorithm, and some work packages related to bidding package. For example, for field work, we have to pay for geophysics and drilling activity, or like electric and sensitivity or geological sample, etc. And we have a small money to buy UAV images to get more new landslide area, let's say. And we have packages for build up the let's say GeoPortal to combine all the component inside that system. Okay, this is the we are in 9 months of the project. Our project in 20 months. So in the very pity Maria is not here, because I want to discuss about the traveling between Vietnam and Italy on the both side. Okay, this is what we done last month. We go to the field. These some images about the fields. We have the people from hydrology, and that guy from geodesy. He's using the UAV Phantom 4 Pro to taking the images. You can see here. So because we have not much money for cover all the UAV images, so we use Google tool plus the best inside Sentinel-1 time series images. So in the right side, we can, if you use that the technology, you can identify what it changes on the ground. So from two images, I mean, we identify which place is the best to select to collect the UAV images. So here is the place we decide to collect the UAV images. Each province we collect about 40 kilometers square of UAV images. So there is some information about UAV what we are using. It is Phantom 4 Pro with a quite high camera resolution, and our map resolution about horizontal accuracy is 5 centimeter and vertical accuracy is 10 centimeter. Is good enough for our study. And this area we use we want to collect the data, and some kilometer along the 32 national road in the Muguncha district and in Banyan districts, we collect the data along the city-5 road, and the green path here you can see is the area we use Google Earth and PSISA to decide what place will be can have the landslide. Okay, this is some example about the URV collecting. Okay. There's some area happened a landslide before, and the people around the area is near the road. And this is a bigger image. And for geological surveys, we have small money to better understand what is underground. So we selected 3 different places, or 2 in the Banyan district and 1 in Muguncha district. So we collect using electrical resistivity with 72 points and along city 150 meters, and we have taking some geological sample, and we've been testing for porosity, cutting resistance, etc. This is the decide to select that area is from Vietnam Institute of Geoscience and Mineral Resources. Dr. Sun is very expert in that. And we have another product which already done in 2 years. Is a land use land cover changes in 2020 and 2019. So with different type of currency, you can see with the kappa and the currency is quite high. It's 90, 91. 2020, and this is some changes. In the yellow box is important factor. This vegetation in 2020 is with 1.8 kilometers square higher than 2019. For instance, in forest also is a bit higher. And our vegetation compared with the barren and other is in 2020 is higher than 2019, 45.4 kilometers square. And this is quite important for us because landslide in the our study areas most affected by human activity, because a lot of landslide happen along the road because they need more land and they cut the slope and make the slope more deeper, and landslide when the big drain or long time drains happen is very most affected strict landslide along. And for landslide data collection, is we have to just new there is a new 2 group of students will develop on that. So hopefully they will have the result done as soon as possible, because we need to use that for data collection in the field. And one of the important factors, so this is a bidding package. We already rent and pay money for that company to support us 6 rain gauge station there. So this is a way to connect that gauge station to getting near real-time rainfall data to our system. It's been give us the data every 30 minutes, 22 hours a day. Okay, this is a location of the rainbow. Is can what we can have in that province. So we have money only for 6 stations. And for publication and student in this period, we preparing 2 publications, and it's submitted in the international conference, geospatial technologies and earth resources. Is linked and is been also published in Pinger book. The first paper is also about WebGIS and random forest for assessing impact of landslide in Banyan district in my province is almost similar to your work have done. Yeah, and I think I will give that for Professor Maria and Basim. It's agree we will publish it. And the second paper is a random forest analysis of land use and cover change using Sentinel-2 data timeshare in my province. Is I already showed you before. We have a 2-year completed, and we are doing for 2007, and in 2018 is not quite good data because it's cloud a lot. So about educational purpose, we have we have one master student already graduated. So he used our data for his thesis, and now we have one more student working in landslide assessment. Is tutored by me. And one student, PhD student. Now he's in the proposal phase, and it's tutored by Professor Chandanang and me. Okay, this is some image about the website and geoportal. So the interface is not so good. It's built up by Angular plus GeoServer, as you know, and PostgreSQL for data management system, and you can click on that, and you can visit the site. I don't think we can. Okay, if we have time, you can see something like that. Can you see the website? No,
no, we see your slide.
Yeah. Okay. Thank you, Basil. This website is almost the interface all I already presented before. So that I just try to put everything, every result in the website. So this website can be shared. This is exactly what we need to build is GeoPortal. So now you can share the better data, not trust. But it's just visualize everything. It's our deep warning system. We need to later. This what similar to what the student done. Start again. Sorry. And I go to the conclusion and discussion. So about the COVID-19 situation in Vietnam is quite stable. Almost people have COVID already, and I think 90% of Vietnamese in the big city already got virus, and it's now become stable condition. And the budget is not ready yet for this period, so we cannot go faster. And number of reports in the second years quite a lot, 33 reports. This is a very Vietnamese standards. So we have to report everything, and that is the rule. We can get money from government, And landslide inventory you need to update because we want to predict something. So we need to landslide for at least several years. We can do it for prediction. That's why we cannot predict anything. Or for instance, we can use something like long short-term memory or INN to predict something in the future. For instance, land use and cover chain, etc. To match them with to combine them with the landslide susceptibility map, and data are available for deep learning algorithm is not yet ready. So we are waiting for UAV team. They will process the images, UAV images, and we hope that we can have the many we can add more extensive landslides in our study, because landslide inventory map we use quite old, is from 2013, and some event is in 2017, is quite old. And the important part I want to discuss later is the exchange scientific group from both countries visit to Milan and Italy to Hanoi. I don't know we can do or not in this period. Okay, thank you for your listening. Thank you. Thank you very much.
Thank you, Kwang, for the updates from your side. I think we will need to have additional meetings between us to set up the work, the common work for for this year, because also we have deployed the GeoNode that we should start filling with data from both countries. And about the mobile application, yeah, and the UAV, we still have to define the works together. So thank you, yes, for the presentation. And I think we can directly continue with Diego, who is going to, yes. I don't know actually if some of the students have questions to Kwang or someone else.
In my side, we have in the plan, we have a discussion session. So there is some point to discuss. For instance, but
yes, but we're a little bit short in the time, yes, at least to finish with this and with the presentations.
Because I want to listen from Professor Marco Abbiati and also the Ludovico about certificate for students, and also Marco Abbiati professor about the way to visit Italy or from Italy to Vietnam. Also, because some people in Vietnam, they change the plan. They don't want to go abroad. I mean, the collaboration project between the Vietnam and Italy, someone changed the way they want to do online, not visit Italy.
So
yeah.
Can I answer maybe?
Yes.
Okay. So you asked about visiting Italy for Vietnamese researchers.
Yes,
So
yes.
we never close the borders for this student visa and research visa. So the consulate of the embassy is supporting in your application if you like to go. It's just matter to fulfill the required documents. I don't have the details about how to apply and which documents you have to provide, but if you go to the website of the embassy, there are all the updated information about the process to apply for a visa to go to Italy. And if you let me know in advance when you are planning to go, I can inform the consulate and let them know that the list of people saying these people are going to apply for the visa to Italy in the framework of the bilateral projects, and there are no problems for you in going to Italy. And I've met quite a few colleagues from Vietnam recently, and they are planning to go to Italy. I mean, colleagues from the Vietnam National University of Forestry, colleagues from the Hue University. They are planning trips for colleagues from the Hanoi University of Civil Engineering. They are already planning to go to Italy in April, May, June. So they are in the process of applying. I don't think you should have any problem in getting a visa. I don't know about the timing to get the visa, so you better ask in time or let me know in time so I can ask the colleagues on the consulate. And I don't know for how long you could stay, because if the student has a contract or a grant, he can have a visa that has the same duration as the grant. If you don't have contract or grants, you have to specify how long you're going to stay and where you're going to stay, so it should not be a problem.
Yeah, thank you.
It's a pleasure. That was all from me, or you asked some other information from me?
Yes.
That's all. Okay, thank you.
Yeah. And for Maria, I think it's more easy than me, right? Because because our group in Italy is 4 people. 4 people. And Pasi, we do again the next presentation, or we do discussion first?
If you want, let's finish with the presentations now, because anyway,
please.
It's the last presentation of Diego, so
Thank
please,
you.
Diego. Thank you.
Okay. Hi, everyone. I will share my screen now. So, okay, I will be presenting about this hybrid approach to classify landslide susceptibility. And this is hybrid because we use both unsupervised and supervised learning. And we will see why would we need unsupervised learning for classifying susceptibility. So first of all, what we want to do is to leverage landslide inventory, that is the recording of the discernible traces of the landslide previous occurrences. And we have the setback that the mechanisms between the different landslide types are very different. For example, we have rockfall that is very different phenomenon from debris flow or a rotational sliding that involves a massive amount of land and it's a completely different mechanisms. And another setback that we have when we classify susceptibility is that we count with previous occurrences from the past, and we cannot say for sure, we cannot ensure that the points in which hasn't happened landslide events in the past will be no susceptible in the future. So we couldn't use landslide inventory directly to feed a machine learning model, because we are telling the model that, okay, if it hasn't happened landslide in the past, then will not happen landslide in the future. And so we are somehow lying to the model. So we need to do something about it. And what is proposed is unsupervised techniques in which we go blindly without target labels, but we want to generate them based on data, and we want to grasp the most frequent conditions of previous landslide occurrences and extrapolate it to the future, and we will have generated data set for feeding a supervised learning approach. So we have machine learning because we have a lot of data, and we want to use a hybrid approach between unsupervised learning and supervised learning. And this is not new. Others have considered this approach for classifying landslide susceptibility. Some of them have used simple models such as PCA, factor analysis, or k-means. And other authors have used more nonlinear methods for example, autoencoders, which is a neural network that learns a representation from Earth observation features. And in this study, what we are proposing is to use the T-distributed stochastic neighbor embedding as an unsupervised algorithm that basically what we do is to learn a probabilistic distribution from distances between samples. So basically, we are computing a probabilistic distribution in which the 2 points that are very near in terms of Earth observation features have a high probability, and very different points have low probability. And then we are computing another probabilistic distribution in a low dimensional space, and we are minimizing the cross entropy between these two probabilistic distribution. I will not enter into many details about it, but it's a very interesting method for learning representations. So this presentation, we have 3 parts. The first of them is a very simple unsupervised learning algorithm that is Gaussian mixture models. That is very known. And we will learn how to use it very simply for computing landslide susceptibility. Then we will move to the work that was done for the previous workshop, in which we distinguished between different landslide types, and we used unsupervised learning and supervised learning for the different landslide types. And then we will move to a large scale work in which we use the landslide data from the whole Lombardy region. And we are using neural networks to leverage this data. So we will go with the first one. The first thing that we can do is that we can plot the features. We have the slope, for example, the elevation and the vegetation index from Sentinel-2 data. And we can plot the landslide in Val Tartano at a single landslide type for simplicity. And we can explore the data over the feature space. We can plot the pairs of features and observe their distribution and where there are the most dense areas over the feature space. And this is very insightful. So we can move to observe what is the distribution of the previous landslides occurrences. In here, we have the orange points that are points in which actually landslide happens in the past, and blue points in which there had been no landslide. So we can simply apply a clustering algorithm such as Gaussian mixture model, and we can observe 2 clusters. We can say, okay, the orange cluster, we will consider this as a point that is have the risk of being a landslide, and we can build a confusion matrix in which we have the predicted labels and the real labels. The Gaussian mixture model produces probabilities, so we have a certain threshold in which we decide whether this is this will be a landslide or not. Okay, so we have, for example, we have the false positives, the points in which we say, okay, this is a point susceptible to landslide, but actually it hasn't happened a landslide in the past. But this wouldn't be a problem because these represent possible novel landslide susceptible areas. On the other hand, we have points in which we found that there is no landslide risk, but actually a landslide happened in the past, and these are the false negatives. And this is is actually a problem because the model couldn't predict susceptibility in a point that is actually susceptible. So we can plot a map, and we can observe that actually the susceptibility mapping is able to predict somehow the landslide occurrences of debris flow solely. And we will move to considering the different landslide types, but separately. So to explain a little bit, we have 3 stages: pre-processing, unsupervised learning, and then we generate a target label for feeding unsupervised learning. So we process the Earth observation data, digital terrain model, and landslide Sentinel-2 data to compute features such as slope, curvature, and vegetation index. We have landslide inventory, and we treat separately the different landslide types. So we reduce the dimensionality with T-distributed stochastic neighbor embedding, and we learn a classifier for over the reduced dimensionality, and from here we obtain a binary dataset, landslide, no landslide, that will be used for several supervised learning algorithms. And then we can map landslide susceptibility. So we have landslide inventory. This is Baltartano data. We have different landslide types, and we can observe that actually, depending on the type of landslide, we have previous occurrences at the top of the mountains or at the bottom of the mountains. So we have the problem that sometimes the landslide previous occurrences encompass the whole range of values, and this is a setback that can be faced with using a large scale data set. Otherwise, treat them differently and treat each rockfall differently from debris flow and so on. So we have Earth observation features, we can plot them, and we will be talking about, you know very well what each of the features means. I will be talking about a little bit a landform classification that is a very innovative approach proposed by these authors, in which they feed an unsupervised learning algorithm to classify the different points in a raster data. And we have 16 distinct classes that give account of the different convexities, the different textures that the land has, and this can be very useful for feeding machine learning models in general. So for the unsupervised learning part, we start with a certain, we tried all the combinations in order to obtain significant representation, and we will see that we can plot them in a reduced dimensionality space with the T-stochastic neighbor embedding. And in here we have the orange points that are previous landslide occurrences, and the blue points that are that nothing has happened. And we can trace a classifier that to the right of the classifier, we classify them as landslide susceptible, and to the left as non-susceptible. And we can see that at the right part of the graph, we can see points in which nothing has happened, but we consider them as novel landslide, as points that are prone to landslide occurrences, but nothing has happened in the past. So we generate the target labels which are binary, landslide, non-landslide, and we feed a supervised learning algorithms. So in here we have a k-fold cross-validation, in which we use as a metric for evaluating performance the area under the curve of the precision recall curve. That is very useful for non-balanced datasets. And we distinguish between the different landslide types. And we have support vector machines as the winner algorithm. And we can plot the final results. And we can see that they differ very much depending on the mechanisms. Of course, we would expect that rockfall is very different from debris fall because the mechanisms are completely different. But we would like to generalize and compute a non-Lie susceptibility map in order to propose risk mitigation strategies for preventing the loss of assets in general. So we proposed a large scale in which we used the whole Lombardy data, and we ignore, in this way, we are ignoring the distinction between the different landslide types, but we are considering the how frequent are the occurrences, and based on this, we are going to compute susceptibility based on the frequent characteristics of previous occurrences. We will see this in detail. So we have a lot of data. If we rasterize this data, we have hundreds of millions of points, and we use the data from these provinces solely in the Alps, in the Lombardy Alps. And now the methodology will change a little bit. We have the pre-processing and supervised learning and the supervised learning. We compute features from Earth observation data, the typical features, curvature, vegetation index. Now we don't distinguish between landslide types, and then we will use a Gaussian filters for considering data proximity and smoothing the raster data. And we will normalize for feeding machine learning methods. So feature extraction, the Earth observation data will be used to feed unsupervised learning that will generate target labels that will be used as ground truth for supervised learning. And on the other hand, will feed supervised learning as input data. So the classifier in the reduced dimensionality will be statistical. So we will consider the frequent patterns. So we will make sure that our generated data set, the points that are considered as risky, will have patterns that were frequent in the previous occurrences. So we reduce dimensionality. We start with a lot of features. We start with PCA. We compute a linear projection in order to reduce dimensionality, and then we reduce dimensionality again with T-distributed stochastic neighbor embedding. That is a non-linear method, so it is able to recognize very non-linear hidden structures in data. So we have our reduced dimensionality. We have in orange previous landslides occurrences, and in blue no occurrences in the past. So this is the data of the past. We produce a density. So we produce a two-dimensional grid, and we compute the density of the previous landslides occurrences. And based on this, we use a certain threshold with which we produce a new data set that are the target labels for the supervised learning methods. So we start from the landslide inventory data. This is the left information is the landslide inventory data as it is, and we generate another binary data set that will be used for feeding a neural network model. So in here, this is a very important issue in here is that we have a trade-off between okay, the threshold that is used in here to pass from the density plot to the generated data set. And this threshold we have to balance it with respect to the final landslide points that will have the generated data set. And this needs the expertise because this will influence in the optimistic or pessimistic behavior of our models, basically. So we have our neural network approach. This is a fully connected neural network. We start with our features and we finish with our endpoint that it is sigmoid classifier, typically used for binary supervised models. We have 80 million data points, 30% used for validation, a batch size of 16,000, a lot of parameters, 11 million. We leverage these techniques because we have a lot of data. And we have these two regularization methods. I will not enter into many details, but they are used for basically smoothing the final result. Is more suitable for computing probabilities. We will see this. Dropout means that we are dismissing certain connections randomly, and this will produce a smoothing effect over the model. And the L2 regularization, maybe you know it, this is equivalent to the Tikhonov regularization. It is basically adding a term in the loss function proportional to the squared of the weights. So it's basically a smoothing method for avoiding overfitting and suitable for computing probabilities, because we will have a more smooth final result, susceptibility mapping. So we have our ground truth, that is the outcome of the unsupervised model. We use a logistic regression as a baseline, so we will compare how this performs with respect to the neural networks approach. We have a neural network model without regularization. We will see that the transitions from 0 to 1 are very sharp, are very fast. So when we use regularization, we will have a more smooth behavior. So this is landslide susceptibility, the probability of a landslide occurring given a certain trigger, namely an earthquake or a rainfall. So to summarize, we start with the landslide inventory, the previous occurrences. These are discernible traces of the previous landslide events. We use unsupervised learning to learn another data set that we will ensure that the points considered as risky have patterns that have been frequent for landslides events in the past. And we have our prediction. That is the landslide susceptibility map. We have results also from RUINON. This is RUINON. We start with previous events. We compute a ground truth, and we can observe that the final result will have, for example, in here, we'll have susceptibility in which no landslide has happened in the past. But we estimate that will be actually it will be susceptible in the future because it contains similar conditions with previous occurrences, and that is this about. This is why we use unsupervised learning as well. Thank you, and questions are welcomed.
Thank you, Diego, for your very nice presentation, and we also want to follow your study, your research. So I'm not from geology. So the first question I would ask you is how you do ground truth for the previous slide. You use ground truth, and how you create that map.
As a baseline, we use logistic regression, and then we pass to the neural network approach. And I maybe forgot to mention that with the activation layer units are rectified linear units, commonly used for neural networks. And this is how we proceed with the supervised part of the method. I don't know if I answered your question.
Can you explain what is ground truth map? Because I missed some slide before. I think ground truth. There is the ground truth map, right? No. Next.
This?
No. I mean the back. No. Next. It's near the last.
Okay.
Yes, about this map, ground truth.
Yes.
The ground truth. Yeah. Sorry. The ground truth, it is basically the outcome of this unsupervised part of the model. So we start with the previous occurrences. We pass this data for the Earth observation data. I will explain maybe here. It is better. We reduce dimensionality. We compute the frequent patterns, and we from this rightmost graph, we generate the ground truth data set. This is how it is done. But we need to train an unsupervised model that is this distributed stochastic neighbor embedding. We train, and from this result, we generate a data set of zeros and ones that we will use as ground truth for supervised. When we talk about ground truth in supervised learning, it means the target labels that we are learning. I hope I answered the doubt.
Yeah. The second question, can you explain again why we need to apply unsupervised
yes.
in this case? Yeah.
Yes.
I'm not so clear about that. Yeah.
Because let me maybe here we have the last one. I think. Okay. So we have, for example, we have previous occurrences, and we cannot ensure that places in which there is no record of landslide in the past, they will have no risk in the future. We cannot say that for sure. And this is why we learn the frequent patterns that the previous occurrences have had in the past, and we extrapolate this to generate our ground truth, which is a binary data set that we will try to predict with supervised learning. So unsupervised learning is for generating a more reliable target data set for supervised learning.
Okay, it's clear.
Thanks.
I seen there's some server on the input data, but based on what you can select that input data for model like NDVI and something complex. Why you choose only 6 parameters factor? You have a lot of factor. Why we choose only 6 factor like this?
Yes, there are different criteria for choosing input data. I can mention, for example, how effective are certain data for predicting susceptibility. For example, I have tried with lithology, and this hasn't been useful, and actually it worse the accuracy of the model. And we have other data sets that are inaccurate. For example, we have the roads. The roads not always involves an excavation necessarily. So sometimes this data set can be misleading. So I used the ones that were suitable for having a good accuracy in the supervised learning approach. But this is just a trial and error process. The criteria is just using what it works, and this involves a high feature engineering process, a very large feature engineering process. For example, in the second part of this presentation, I just tried all the combinations between 7 features, all the combinations. And this is a very, this is a brute force approach that in which we can ensure that we are obtaining the best combinations of features for having the best accuracy as possible. But in a machine learning work, actually the feature engineering part is the most hard one. Because the data scientists need to spend more time in choosing the right features. So there are a lot of criteria, but the most useful, I would say, that is the one you have to use the feature that works, basically.
Okay.
If I may ask a bit also, I have questions. So I didn't understand from the point of view of validation, because there is this term that you're introducing as ground truth that I think probably it gives us a bit of confusion also to me. So in the end, with which part did you manage to validate your outputs? With what you were validating your outputs?
So I will start from here. Okay, so in here we have the whole data.
Yeah.
And we use the features that I showed before, that is curvatures, DTM, slope. So, and then I apply a filter because we don't care about these areas in the south. We don't care pretty much about it. So I established a criteria to dismiss them, which is elevation, basically. Elevation above 300 meters are considered for the analysis. So by applying this filter and over a 10 by 10 meters raster data, we have 80 million points. And with these 80 million points are shuffled, are randomized, and then the 30% of them are used for validation in each neural network epoch.
Sorry, you mean you mean the points that are above 300 meters of elevation? Yes. Okay.
Yes.
But so, you mean the areas that they don't have landslides by the inventory, or just inventory?
Actually, I'm using I'm using the inventory. Actually, the inventory is not used in the supervised part, but only in the unsupervised part. We have here the landslide inventory used for the unsupervised part, and from here we generate the dataset. This is, I think it is clear. So we will have different raster data, convexity and slope and so on, with the same size as the landslide, non-landslide datasets target labels. So we have something like this, a raster under the other, a tower of rasters. And okay, we apply a filter, the one I mentioned, and by applying this filter, we have the 100% of the data that are 80 million points. 80 million points, and this is split. We have a part of training data and another part of validation data. And as a metric, I used the typical metric used for binary problems.
Yes, the area under PRC.
Yeah,
But
yeah.
no, okay. I mean, okay, more the question that was like, for example, the parts that you're saying that most probably there's not going to be landslide. How did you verify this one? Because you're saying it's ground truth. This is what is confusing me from my point of view.
Ground truth is a term used in supervised learning, but in here, yeah, I think now I understand your point. In here, what I ensure that the points that are considered are ones in the generated data sets. I am ensuring that they are similar. They share common characteristics with previous occurrences. Because I built a frequency plot, the one in the middle, and if we need to.
Okay, yeah.
Okay, thanks. If the certain grid in the reduced dimensionality is above this threshold, we are ensuring that this is frequent, but the threshold is an hyperparameter of the model, and this hyperparameter of the model will have influence over the final landslide points of the generated data of the ground truth.
Okay.
See, so how we verify this? As I mentioned, we need an expert, and this needs to be in hand with the risk mitigation strategies, because this will, based on this threshold, that is an hyperparameter, will depend the final optimistic or pessimistic behavior of our model. So how I decide this threshold, basically ensuring that the amounts of ones in the leftmost graph is equal to the ones in the rightmost graph, and that was my criteria. So I'm dismissing the points, the risky points that are infrequent in the landslide inventory, and I am replacing them with points that are frequent and share common characteristics with previous events.
Okay, thank you.
Thank you. There's another question.
Yeah,
I would like to make a question.
Mm-hmm.
I have just two small questions. The first one is when you apply the unsupervised learning, you compute this so-called ground truth, but there are some areas in which previously there were some occurrences of landslides, and then maybe they are like colored in blue, like there is no landslide risk. I understand.
Mm-hmm.
It would be a problem from the practical point of view for the output of the final supervised phase of the model. That's the first one. And the second is if you consider there is a weakness of the proposal in the case you want to enlarge the study area, like, I mean, total region, if it's more heterogeneous, if you consider it would be a risk in the procedure.
Yes, yes. Thank you very much for the questions. I will answer the first one. I will go in this. Okay, so when we have such nonlinear dimensionality reducing, this will produce problems in the supervised part because it will be more hard to learn this pattern. So what happens is that the generated ground truth will be very hard to predict. So as complex is the unsupervised methodology, it will be more complex to predict it. So we will need more data. And that's it, because the patterns that this T-distributed stochastic neighbor embedding can find are very nonlinear, are very complex, and are very difficult, hard to understand.
Có bị sốt không? Có bị sốt không?
Okay. So yes, that happens with that. Those are the problems that can be generated by applying the unsupervised learning. But for example, in here we used a different criteria, a linear classificator, and in here to learn a susceptibility mapping needs less data, basically. So regarding the extrapolation, this is a big problem. Actually, this is the reason I didn't use data out of the Alps. Because if we need to extrapolate, in my opinion, what we need to do is dismiss the elevation, because the elevation will depend directly in the mountain chain that is being analyzed. It is not the same doing it in the Himalayas than in the Alps. Of course, this is a big problem. So I think we would need to dismiss data that is collected with different criteria. That in one hand, and on the other hand, extrapolable data need to be used. For example, if we compute a vegetation index, it has to be by means of similar acquisitions, Sentinel-2 data, but maybe data that only is taken in summer, because if there is snow, there will be less vegetation that can be observed by the Earth observation acquisition. So that is actually a good question, and we need to take care about the features we use. It can only be this can only be features that can be used in other parts. Elevation is not one of them, so needs to be dismissed.
Thank you.
Thank you. Any more questions?
Can you hear me?
Yes.
Okay. This is not a question. This is just a suggestion. Your results are really interesting. I suggest you to compare your results with those obtained by Basil. That were exactly, again, computation of accessibility on the same area.
Yes, yes, for sure. I used a different, for my results, I used a different color bar, so maybe it's it's difficult to compare, but for sure, this is a work that needs to be done. It is important that the susceptibility computations have a smooth behavior, in my opinion, because this is a probability. So for example, in the left bottom graph, we have very sharp variations. The transitions between 0 and 1 are very short, and this is not suitable for probabilities. So we need to have a smooth susceptibility mapping, in my opinion, in order to have a smooth transition between risk and no risk, because this is a natural behavior, so we expect smoothness in the phenomenon. Thank you for
I think definitely we have to compare. Also, we have to compare for which landslides they were done. So because in the end, you did it for all or for
for all of them,
okay,
without distinguishing.
Okay.
Yes.
Okay, I think we should yeah, keep in touch and do a comparison.
Yes.
Sorry, do you consider also time for the different type of landslide?
No,
this
is a timeless landslide mapping, susceptibility mapping. Yeah, basically, this would be interesting to compute this over time, of course, because this is a process that happens on time, and the displacement of the land masses happens over time. So that is the ideal way of computing landslide susceptibility.
Because I heard that you said about rainfall and earthquake trigger in some slide in the middle.
Yes, because those are the common triggers. So when we talk about susceptibility, is the probability of landslide, that is okay, but a certain triggering needs to happen, and this is not taking the climatological issues and seismological issues are not considered in this analysis. They are treated all of a unique susceptibility, landslide susceptibility. Any more questions?
I have one comment. From my point of view, soil and different type of geology is important for landslide factor. So I think you can try again with them, because if you want to publish a paper, etc., I think 6 classes is not attractive to.
Yes, maybe it depends on the combination that if you use litology, it may be okay if you use it combinedly with other Earth observation features. And yes, this is part of the feature engineering. That is a very try and error process.
As a why you should explain that your study area is small, or there is a specific, and we don't need to apply for geology map or something like that. Otherwise, a bit difficult to understand why soil type, geology, and some other is not important in.
Yes, and also fault mapping. Yes. Any more comments?
I don't see, I don't hear. Okay, thank you, Diego.
Thank you.
Quang, I think we're a little bit over time. So
Yeah, so I think we need Maria to have decide some things. So I just
I'm not sure.
Yeah, I just have one question. Not question. I mean the comment. Ludovico, professor. Vietnamese students they need certificate for the course like attendance or something, maybe more if you can sign. Please help us to have a certificate because some of them is from university. They want to show the university that they attend the course because they spend time during the working hours. So they need the certificate to make everything clear. So please give us and we very want to cooperate in the writing paper and sharing also the data and model. If we have an idea about if you want data to checking the model and something like that, let us know and we can share. So we can work together to have some paper, something like that, in the future. Because next month, I think I have the map from UAV, so in outside we can improve landslide inventory and we can know which plate with large enough landslide event to do something more than before. I think, yes. Yes, yes. Yeah, I finished. Yeah.
Okay. So I'm not sure about the question that you had for the UAV, Kwang.
Yeah, because we want to apply like deep learning like CNN or maybe LSTM, long short-term memory, something like that. So we need to have
You
better
collect data.
Yes, yes.
But I have a
Because
question. You sent us 2 landslides last year, I think, like the areas of 2. Do you know when they were activated, or do you have active landslides in your areas, similar to what we have?
We have 2 different data set now. We have the last landslide inventory I sent to you, and the student doing done the job in that data set is mainly collected in 2013. It's long, very long history. And they use they go how they collect that. They went to the field, collect some, and also someone using Google image to identify the landslide. But now it's almost area is covered by forest, trees, and
so it is not active anymore.
Yeah, and we have update data is from in 2017, but right now I don't have that. I have very small area because they not validated that data, so I cannot have that data right now. And the last year we visit fields and we collect around 40 new landslides, but they are quite small. They are along, most of them along the road.
Okay.
And now with UIV images, I hope that we can have more landslide inventory. Yes. Because the UIV we can go deeper inside and we can go left or right far.
Yeah.
Otherwise, the take time. Yes.
Okay.
Yeah. Yes.
I think at this point I can stop the recording also.
Yes. Yes. Yes.